All right, here are the answers to the mental math. We have an addition problem, or we're finding the sum between those two. So 4.5 wins the sine game, and we take 1.5 away from 4.5, and we get 3.0. Okay, the next one is 8 times 4 is 32, and that would have been 32 times 10 to the 10th. However, we're going to have to make it 3.2 and add an exponent, so it would be 10 to the 11th. Okay, letter C. Okay, so 0.005, if we multiply it by 30, this times 30, what we get is 150 with 3 things behind the decimal point, so that would be 0.15. So 30 is basically our scale factor going this way. Okay, so this times 30 equals this. So this times 30 equals 30. So we're going to get n equals 1 for that. Okay, you could also have done this off to the side and done 30 cross product. Okay, and that's okay if sometimes you need to do it on paper, because that one's a tricky one to do in your head. All right, now we're going to convert. This was wrong on your paper. Negative 15 degrees Celsius to Fahrenheit. So what we do is negative 15 divided by 5 is negative 3. Negative 3 times 9 is negative 27. Negative 27 plus 32 is positive 5 degrees Celsius, or Fahrenheit, sorry. 12 times 2 is 24, and then a third of 12 is 4, so 24 plus 4 is 28. And then a third less than 60. Well, a third of 60 is 20. Less that from 60, we got $40. Okay, now we are jumping into this idea of the Pythagorean Theorem. This is pretty cool. Okay, the longest side of a right triangle, which I have here, is always called the hypotenuse. And I just spelled that incorrectly. Hypotenuse. Okay, every right triangle has a hypotenuse, and it's always opposite, the opposite side of the right angle. So if you stood in the right angle, looked across, you're looking at the hypotenuse, okay? The other two sides have special names, and they are called legs, okay? So you are either a leg or a hypotenuse in a right triangle. And the legs share the right angle. Okay, they make up the right angle. Every right triangle has a property that makes right triangles very important in them. They actually have a lot of properties. Okay, the area of the square drawn on the hypotenuse. So if I took this and drew a square here, I want you guys to do that too. Draw a square and then draw another square that matches your leg here. Okay, so we've got 3 squares stuck to our triangle, and the area of all these squares, the area of this square plus the area of this square, happens to be the area of this square. So let's look. The area of this square here is a 4 by 4, okay, which is 16 units. Okay, the area of this is a 3 by 3, which is 9 units. And then the area of this is a 5 by 5, which is 25. And for every right triangle, when you add the areas of the sides, if you had an invisible square here and an invisible square here, you add these two areas, you're going to get the area of the square that the hypotenuse makes. So 16 plus 9 is 25. And that happens in every right triangle in all the world, okay? And this property of right triangles was known to the Egyptians in as early as 2000 BC. So this is a ancient, very long ago discovery, okay? And it is named for a Greek mathematician who lived about 550 BC. The Greek's name was Pythagoras, hence the name Pythagorean Theorem. And the property is called the Pythagorean Theorem. The Greeks are so proud of Pythagoras that they have issued a postage stamp that illustrates the theorem. And it's in your book. There's a picture of it. It's super exciting. Okay, let's look at example 1. Draw a square on each side of this triangle and find the areas of each square. Okay, so yes, we kind of have to run into the writing, and that's okay. And it's okay if your square is not perfect, it's just a sketch, okay? So we're going to find the area of each of these squares. Well, the area of this 8 by 8 square is 64 centimeters squared. This one is 36 centimeters squared. Length times width, right? Or side squared. Now, what is the area of this other one? Okay, well, if the side is C times C, we're just going to say the area is C squared. Okay, and the letter C is most commonly associated with the hypotenuse. Okay, so can we guess then what the area of this is? Or do we have a way to predict that? Well, what did we say? We said this area plus this area equals the area of the big one. So 64 plus 36, this must be 100 centimeters squared in there. Okay, so if the area is 100 squared, or C squared equals, not 100 squared, C squared equals 100, can we figure out what just C is, just the length of the side C? Well, what times itself makes 100? Looks like C must be 10 centimeters long, right? And we're going to talk about stuff like that in the next lesson, finding square roots. Okay, example 2, go ahead, find the length of A. Now we could do this again by drawing squares. My squares are not to scale because I didn't want to make it so big, but I know 12 times 12 is 144, and 13 times 13 is 169 because we're memorizing that, right? And A squared, now be careful, a lot of us are going to want to do 144 plus 169, but it's not. This is our hypotenuse square, so it's our leg squares that add up to our hypotenuse squares. So it's 144 plus something equals 169. So let me write it this way, 144 plus A squared equals 169. So now we have it algebraically. And so now we get A squared equals 25 when we subtract, which is a nice perfect square, which means we can get the length of A because something times something equals 25. Something times itself equals 25. A actually will equal 25 inches. Okay? Example 3. Find the perimeter of this triangle. Well, it's 4 plus 3 plus C. But they actually want us to know the length of C first, right? So I could draw my squares for a while, and then I'll teach you a way not to have to draw these squares, but the book is pretty square dependent here. So this square would be 16. This square would be 9. Yeah, squared. And this square would be C squared, right? In this case, we have our two leg squares, right? And we're looking for a hypotenuse. So we'd say 16 plus 9 equals C squared. Okay, which is 25 equals C squared. So C must be 5. Okay. So now the perimeter is 3 plus 4 plus 5 centimeters, right? Which is 12 centimeters. Okay, moving on. Last example. Draw squares on the sides of this right triangle. Okay. And I'm noticing we are missing a leg. Oh, we're missing all of them, sorry. Okay, so if we do this and find the areas of each of these, this is a squared, this is b squared, and this is c squared. Then write an equation that shows the relationships between the areas of the squares. Okay, and this is the Pythagorean theorem. It is a squared plus b squared equals c squared. That is the magic Pythagorean theorem. They're showing us where it came from. Now, these are always, I want you to write this, these are always legs. And this is always the hypotenuse, but you can just write hype. So the leg squared plus a leg squared equals the hypotenuse squared. Sometimes people stick the hypotenuse over here by accident, and that can cause all kinds of issues when you're solving for the side of a triangle. Okay? So now we have practice. You can go ahead and jump into that and come back and check and see how you did. I do not have a solution manual, so the chances of me making a mistake are great, and I apologize for that. Or maybe you're welcome if you like to get candy. Okay, example A, draw squares of the triangles as you work out problems A through C. So I'm going to draw a square. I'm really drawing rectangles because I don't have enough room, and that is totally fine. Okay, so this is A squared. Ooh, 24 squared. Does anyone know that? I sure don't. I know 25 squared is 625, so I'm going to go ahead and be okay with this, but chances are I can make a mistake once we start doing this. But I have someone next to me checking my work too. So it looks like I got this. Oops. And let's try this one. And it looks to me like my assistant is agreeing with me. And so now to find A, we write it this way. I might write it right here. A squared plus 576 equals 676. Okay. And then subtract, and it looks like this is a nice, A squared equals 100. So the length of A must be 10. We call it the square root of 100. Or what times itself makes 100, 10. Okay, and I'm going to say units because they didn't tell us what that was. Okay, and letter B. Theorem to find B. So I'm just actually going to write this. A squared plus B squared equals C squared. I'm writing the formula, right? And then A is going to be 9. B is missing, and no, it's not. They messed it up. I think that should be C. So I'm just going to do leg squared plus leg squared equals hypotenuse squared. I don't like where they put the B. I would have rather this said C. Okay, so it's 9 squared plus 12 squared equals B squared, even though it should be C. Okay, get over it, Mrs. DeShiel. So 81 plus 144 equals B squared. And what we get there is 225 equals B squared. Now that is a perfect square. Something times itself does equal 225, and that would be 15. Okay, units. Oh, yeah, we're supposed to draw the boxes. My assistant just told me. So I'm drawing the boxes so no one calls me or maybe she gets a candy right now. And this is 81, so 144 plus 81. This was 225. There we go. Drew the boxes. Okay, so I'm going to draw the boxes again. My fake squares, right? Okay, so this is 64, this is 36, and this is C squared. So we could do 64 plus 36 equals my hypotenuse. Now the hypotenuse was laying down on the bottom, but I noticed that because it's opposite my right angle. So my legs were 8 and 6. And one thing you're always going to know too is your hypotenuse is always longer than your legs. So if you got a hypotenuse that's shorter than one of your legs, then there's a mistake in there, okay? So we get c squared, and I believe, is that 100 again? Isn't that nice? So c equals 10. Dimensions are in feet. Nice, okay. And that's a 10. All right, that was a fun lesson. I love that stuff. I'm sure you did.